Mysterious objects in space could be Dyson spheres, giant Dyson spheres, according to what scientists claim. There's something poetic about humanity's attempt to detect other civilizations somewhere in the Milky Way's expanse. That's our galaxy. There's also something futile about it, but we're not going to stop. There's little doubt about that. One group of scientists thinks that we may already have detected technosignatures from a technologically civilization Dyson spheres, but the detection is hidden in our vast troves of astronomical data. A Dyson sphere is a hypothetical engineering project that only highly advanced civilizations could build. In this sense, advanced means the kind of almost unimaginable technology and prowess that would allow a civilization to build a structure around an entire star. These Dyson spheres would allow a civilization to harness all of the star's energy. A civilization could only build something so massive and complex if they had reached level 2 in the Kardashev scale of civilizations. Dyson spheres could be a technosignature, and a team of researchers from Sweden, India, the UK, and the US developed a way to search for Dyson sphere technosignatures they're calling Project Hephaestus. Hephaestus was a Greek god of the fire and metallurgy. Hephaestus also means volcano. Now, therefore, publishing their results in the monthly notices of the Royal Academy of Sciences, the researchers titled Project Hephaestus Second 2 Dyson sphere candidates from Gaia DR3 to MASS and WISE. The lead author is Matthias Suazo, a PhD student at the Department of Physics and Astronomy in Uppsala University, Sweden. This is the second paper presenting Project Hephaestus. The first one is in the link here. They said, in this study, we present a comprehensive search for partial Dyson spheres by analyzing optical and infrared observations from Gaia, 2 MASS and WISE. These are telescopes. The authors write, these are large-scale astronomical surveys designed for different purposes. Each one of them generated an enormous amount of data from individual stars. This second paper examines the Gaia DR3, 2 MASS and WISE photometry of 5 million sources to build a catalog of potential Dyson spheres, they explain. Combing through all of the data is an arduous task, and in this work, the team of researchers developed a special data pipeline to work its way through the combined data of all 3 surveys. They point out that they are searching for a partially completed sphere or spheres which would emit excess infrared radiation. This structure would emit waste heat in the form of mid-infrared radiation heat. In addition to the level of completion of the structure would depend on its effective temperature, Suazo and colleagues write. The problem is they're not the only objects to do so. Many natural objects do too, like circumstellar dust rings and nebula. Background galaxies can also emit excess infrared radiation and create false positives. It's the pipeline's job to filter them out. A specialized pipeline has been developed to identify potential Dyson sphere candidates, focusing on detecting sources that display anomalous infrared excess that cannot be attributed to any known natural source of such radiation, the researchers explain. And there's a flowchart here showing the pipeline that looks like what it looks like. The pipeline is just the first step. The team subjects the list of candidates to further scrutiny based on factors like H-alpha emissions, optical variability, and astrometry. 386 sources survived the last cut. Of those, 328 were rejected as blends, 29 were rejected as irregulars, and 4 were rejected as nebulars. They left only 7 potential Dyson spheres out of about 5 million initial objects, and the researchers are confident that those 7 are legitimate. All sources are clear mid-infrared emitters with no clear contaminators or signatures that indicate an obvious mid-infrared origin, they explain. There are the 7 strongest candidates, but the researchers know they're still just candidates. There could be other reasons why the 7 are emitting excess infrared. The presence of warm debris disks around our candidates remains a plausible explanation for the infrared excess of our sources, they explain. But their candidates seem to be M-type red dwarf stars. The debris disks around M-dwarf stars are very rare. However, it gets complicated because some research suggests that debris disks around M-dwarfs form differently and present differently. One type of debris disk called extreme debris disk, EDD, can explain some of the luminosity the team sees around their candidates, but these sources have never been observed in connection with M-dwarfs, Suazo and his co-author writes. That leaves the team with 3 questions. Are our candidates strange young stars with flux does not vary with time? Are these stars M-dwarf debris disks with extreme fractional luminosity, or something completely different? After analyzing the optical MIR photometry, we found 7 apparent M-dwarfs exhibiting an infrared excess of unclear nature that's compatible to our Dyson sphere models, they write. And there are natural explanations for the excess infrared coming from these 7, but none of them clearly explains such a phenomenon in the candidates, especially given that all are M-dwarfs. The researchers say that follow-up optical spectroscopy would help in understand these 7 sources better. A better understanding of the H-alpha emissions is especially valuable since they can also come from young disks. In particular, analyzing the spectral region around H-alpha can help us ultimately discard or verify the presence of young disks, the researchers write. Additional analysis are definitely necessary to unveil the true nature of these sources, they conclude. The article was originally published by Universe Today, and this is on Science Alert by Evan Coe. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.